the interpretation of NMR signal. Okay, there are certain rules. For that, before you go to the rules, you should know what are different values of chemical shifts depending on the type of proton it is present. So if it is a proton which is present on sp3 hybridized carbon, it will generally have the chemical shift value between 0.9 to 2 ppm. Okay, now in that there are three types. If it is attached to primary carbon, the value will be around 0.9. If it is a secondary carbon, the value will be approximately 1.3. And if it is a tertiary carbon, the value will be around 1.7. Now, if it is the hydrogen is attached to a carbon and that carbon is at alpha position to a, okay, then the value of delta will be 1.5 to 2.5. So this Z may be carbon, oxygen or nitrogen. Okay, where this will be useful? This will be useful in compounds which contains ketonic groups. Okay, aldehydic group. In that case, this value is important. We can identify presence of aldehyde and ketone. So next is acetylene, like it is 2.5. Then sp3 hybridized carbon attached to atom, like in case of alcohols, alkyl halides and amines, the value between 2.5 and 4. Then sp2 hybridized carbon, the value will be between 4.5 to 6. Hydrogen attached to aromatic ring, the value will be 0.5 to 8. Hydrogen attached to carbonyl group in aldehydes, value will be 9 to 10. Please don't confuse this hydrogen with this hydrogen. Here it is directly attached to carbonyl, here it is attached to alpha to the carbonyl group or the double bond. Then carboxylic acid hydrogen, acidic hydrogen, you can see it is highly de-shielded, its value is 10 to 12. Then you have alcoholic or amine hydrogens, the value is between 1 to 5. Now you are expected to remember all these values, and don't worry, you have also remembered IR value, so this is little bit easy from that. So important tips interpreting an NMR spectra. First set of rules is regarding chemical shift values, that is the shift values we have seen over here. Okay, so tau value or delta value, so relationship between tau and delta is, say, tau is equal to 10 minus delta. So tau values of methylene will be more than methylene, more than methine. So this follows this table. Tau value depends on nature of substituent on carbon atom bearing proton, that is greater the electronegativity substituent electronegativity of the substituent, lower is the tau value or higher is the delta value. Okay, it is, the values are exactly opposite. If tau value is larger, delta value is smaller. If delta value is smaller, tau value is greater. So tau value depends on type of hybrid orbital holding the proton. So sp3 has higher value, then followed by sp, followed by sp2. Tau value of aromatic proton is always less than 4 ppm. So if you talk about delta value, it will be always around 6 ppm, more than 6 ppm. Okay, and tau value depends on the degree and nature of the substitution. We are still in the first set of rules. Tau value of aldehydic protons are usually lower than 0.8 ppm or even still lower. So what about the delta value? It will be more than 9 or near to 10. Tau value in cyclic compound is always higher than that of any proton. Protons in cyclopropane has maximum tau value. So proton in cyclopropane will have minimum of tau value. So tau value of hydroxyl and NH proton depends on temperature, solvent concentration and neighboring group. That is because they are forming hydrogen bonds. Okay. For example, alcoholic hydroxyl, it is 4.5 to 9 tau, and for phenolic hydroxyl it is between 2 to 6 tau. For hydroxyl, for carboxylic acid, tau value is 0.5 minus 0.5 to minus 2.0. So if you consider delta, it is more than 10. It may be between 10.5 to 12. Number of signals in an NMR spectrum tells the number of sets of the proton in different chemical environments. It also tells number of equal protons causing splitting of the signal. These two rules we have seen it already. So these are applications of proton. Now what we are left is C13 NMR. Okay, that C13 NMR we will see in the next lecture. So before going further, let's see the limitations of NMR, conventional NMR. It lacks sensitivity. About 1 ml of the sample, at least of 1% concentration is required. Okay, overlapping of spectra in some compounds, if that happens, it is extremely difficult to interpret. No information about the molecular weight is given, but relative number of different proton sets should be already known. Then only you can interpret the signal. So you should know how many protons are present in the molecule before you go for an. That can be done with CHN analysis, a different method of analysis. You basically determine the how many carbon, hydrogen, nitrogens are present in the compound. Mostly only liquids can be studied. Solid polymers are preheated with solvents. So that's it. C13 NMR we'll see in the next lecture.